Hello everyone, we shall be discussing redox reactions today and what redox is all about. So redox actually stands for reduction, oxidation, reaction. So this means as reduction is happening, oxidation is also happening at the same time. So that means redox reaction is a form of simultaneous reaction such that as oxidation is occurring, reduction is also occurring at that very period. So I'll be talking about each of them, what you understand by oxidation can be viewed from oxidation means loss of electron. Let's take a look at sodium for example. So this sodium atom having 11 electrons in total. This sodium atom. So when it's becoming an ion, that means this atom's electron is being lost. So when it's losing electron, it becomes sodium ion. So this is now sodium ion. That means it's a loss of electron. We'll write this with minus electron to become sodium ion. But most of the time in chemistry, don't like writing it in this form, that is minus electron. We prefer to make it plus. So in some textbooks, you can actually see it this way. So sodium minus electron to give you what? Sodium plus. So in some textbooks too, you are likely to see it in the form sodium to be sodium ion plus electron. So we call this oxidation in terms of electron transfer. This is oxidation. So it means loss of electron, which is this. So another meaning of oxidation is that oxidation is the addition of oxygen. When you have like this sodium still, let's use sodium plus oxygen to give you sodium oxide. Is equation balanced? No, the equation is not balanced. So place 2 here to make sodium balanced. Then oxygen is 2 here. Oxygen is 1 here. So oxygen is not balanced yet. So place 2 here. So you place 4 here to make sodium 4. So sodium is balanced. Oxygen is therefore balanced because oxygen is 2 here. Oxygen is 2 here too. Sodium is 4 here. Sodium is 4 here. So the equation is balanced. So in terms of addition of oxygen, we say there is oxidation. So addition of oxygen. Another one is addition of highly electronegative elements. So when you check the periodic table, you get to know that the electronegativity increases across the period. That means going from left to right. Nitrogen, oxygen, fluorine, chlorine. These elements are highly electronegative. So if you can add any of these to what you have, we call it oxidation. So oxidation takes place when you add highly electronegative elements. Example, you have, let's say, sodium still plus chlorine to give you sodium chloride. The equation is not balanced. Place 2 here, place 2 here. To make sodium 2, sodium is 2 here too. Then chlorine is 2, chlorine is 2 here too. So the equation is balanced now. So addition of highly electronegative elements is also called oxidation. So another one, which is number 4, definition of oxidation. Oxidation means the removal of hydrogen. Oxidation means removal of hydrogen. A good example of that is when you have hydrogen sulfide reacting with chlorine gas to give hydrogen chloride gas. Oxidation is the increase in oxidation number. Example, you have ion 2 moving on to ion 3. So you get to know that the oxidation number of this one is +2. Oxidation number of this is what? +3. So an increase in oxidation number is still what? Oxidation. What then is reduction? Reduction is just the opposite of oxidation. So a good example of that is chlorine atom getting 1 electron to become chloride ion. So because chlorine is diatomic, this reaction will occur again. So chlorine atom again plus 1 electron to be chloride ion. To get Cl2 plus 2 electrons to give 2Cl minus. So why did this accept 1 electron? Because chlorine only is having an atomic number of 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So at this juncture, chlorine is 17. For it to attain octet configuration, it will have to accept 1 electron to get to what? For the outermost electrons to be 8. So 1 electron will be added to this. When it's added, this chlorine atom, then 1 electron will be added to it to give chloride ion. So the innermost electrons will be 2 followed by 8. And this is the electron that is being added to it. So to make this octet configuration, if you have to put this, that means chloride atom get 1 electron, chloride ion, and that is what is here. So, but because chlorine is diatomic in nature, it has to repeat itself to be this. So that's why I wrote it in this form, chlorine gas. There is addition of electron to this. We call that reduction. We did the first one, which is loss of electron. The second one is the addition of oxygen. So example of this is reduction of zinc oxide by carbon to zinc. Then carbon 2 oxide gas is formed. Here, the zinc is being reduced from zinc 2 to just 0. And what actually caused that? The removal of oxygen. So reduction is is the removal of oxygen. The next is addition of highly electronegative elements. So reduction in this case is the removal of highly electronegative elements. Example is iron 3 chloride reacting with hydrogen gas to produce iron 2 chloride, and hydrochloric acid is formed. So let's check if the equation is balanced. The equation is not balanced because hydrogen is 2 here and nitrogen is 1 here. What do we do? Let's place 2 before the hydrochloric acid. So this hydrochloric acid, so that means this 2 is affecting hydrogen, is also affecting chlorine. So hydrogen is 2 here, hydrogen is 2 here, hydrogen is balanced. Chlorine is 2 here plus 2 to make it 4, but chlorine is just 3 here. What do we do? Place 2 here to make the chlorine 6. Iron is also 2 here. So let's place 2 here to make the equation. I think it should balance now. So iron is 2, chlorine is 6, chlorine is 4 plus 2, that's 6. Hydrogen is 2, so the equation is. What does this mean? This means that the oxidation number of iron here is plus 3, the oxidation here is plus 2. Chlorine, it's actually being taken away from this iron 3 chloride and it's being reduced here to iron 2 chloride. So in terms of removal of highly electronegative elements, we call that reduction. The fourth one, for the example, let's still use sodium. I don't know the reason I'm using sodium lately. So sodium plus hydrogen gas to give you sodium hydride. The equation is not balanced. We place 2 here to make hydrogen 2, hydrogen is 2, sodium is 1 here, place 2 here to make sodium 2. The equation is not balanced. So the addition of hydrogen is still reduction. The last one, which is that will be reduction in oxidation number. So let's take this Cr2O7 2 minus, so Cr3 plus. So from here, how do you get the oxidation number? This is chromium. Won't get the oxidation number of chromium in this. That will be 2 times Cr plus oxidation number of oxygen in any compound is always -2, except for peroxides. So in this case, this is -2 minus 2 times, that is subscript of 7, minus 2 times 7 is equal to, so these are ion. So the oxidation number of ion is always the charge on it. So the charge here will be -2, that's equal to 2, minus 2. So from here, this 2Cr minus 14 is equal to minus 2. This is 2Cr is equal to minus 2 plus 14. Then you get 2Cr is equal to plus 12. Divide both sides by 2. The oxidation number of chromium here then becomes plus 6. So it's moved from plus 6 to plus 3 here. So that means there is reduction in oxidation. In terms of oxidation number, we see reduction is the decrease in oxidation number. Most of the reactions we have undergo redox reaction. There are actually exceptions to this. One of the exceptions is neutralization reaction. In neutralization reaction, what is neutralization reaction? Neutralization reaction is the reaction between an acid and a base to give salt and water. So A good example of an acid is HCl, hydrochloric acid, and a base is sodium hydroxide, to give sodium chloride salt plus water is formed. You want to check if this is actually undergoing oxidation reduction reaction. If it's not undergoing oxidation reduction, that means this is non-redox. So how do we do that? The oxidation number of oxidation, let's do that in terms of oxidation. Let's check chlorine. Chlorine is -1 here, chloride is -1 here, chloride is -1 here too. No increase, no decrease. Let's check sodium. Sodium is +1 here, sodium is also +1 here. Oxygen is -2 here, oxygen is also -2 here. So it shows that none of this is undergoing oxidation, none of this is undergoing reduction, because there's no increase in oxidation number of any one of them, and there's no decrease in oxidation number of any one of them. So this is non-redox reaction. So another one is precipitation reaction. In precipitation, the first reactant is soluble. The second reactant is also soluble. Then the products you have C plus D. One of them will be soluble, either dissoluble or insoluble. Then the other will be insoluble. So depending on how you write that. So let's take for example. Just note that all chlorides, there are some things you need to know in chemistry. All chlorides are soluble, except the chlorides of lead 2. Lead 2 chloride is insoluble. Silver chloride is insoluble. Barium chloride is also insoluble. Just take note of this. We have all nitrates. All nitrates are soluble. And many others. But let's talk about another one is all sodium, potassium, and ammonium salts are soluble. So anytime you come across sodium, potassium, and ammonium, they are soluble. So let's test for precipitation. Precipitation, let's use sodium chloride. For example, sodium chloride reacting with silver nitrate to give AgCl plus NaNO3. This is insoluble, and this is soluble. This is soluble. This is soluble. So when you come across this, get to know that based on what I said, that the reactants in a precipitation reaction, the reactants will be both soluble, while the product, one of the products will be insoluble. So in this case, this is insoluble. Therefore, this is a precipitation reaction. We want to check if precipitation reaction is an example of redox reaction. So how do we go about that? The first thing we have to talk about is this. This is +1 here. Sodium is also +1 here. Chloride is -1 here. Chloride is also -1 here. Silver is +1 here. Silver is also +1 here. Nitrogen is +5 here. Nitrogen is also +5 here. Oxygen is -2 times 3. So this is -2 times 3. Let me just write -2, and this is also -2 here. Get to know that none of them is undergoing oxidation and none of them is undergoing reduction. So therefore, precipitation reaction is a non-redox reaction. The two exceptions are precipitation reaction and also